question for us. X plus 2 over 9 equals 1 minus x plus 5 over 2. Can anyone give us an idea on what we need to do first? What would you do first? What would you do first? What is the idea here? What do we want to do? Remember, clean it up. How would you think about this? What is the first step? Anyone would like to try? Give us an idea. What would you like to do here? What bothers you if you want? What bothers you here?
The 9 and the 2.
Correct. So let's find the least common denominator. Can anyone tell us what is the least common denominator?
18.
Yes, because they have nothing in common. Yes, thank you, thank you, thank you. Of course. So therefore, we are going to multiply everything by 18. I'm going to multiply this by 18. I'll multiply this by 18. And I'm going to multiply this by 18. This is the first term. This is the second term. This is the third term. When I multiply by 18, I simplify. And I'm really multiplying or distributing 2. So I have 2x plus 4. 1 times 18 is 18. I copy the negative sign and I open parentheses. Of course, I'm going to simplify, and I get 9. I'm only going to distribute 9 to these two terms, because my idea was to eliminate fractions. Eliminate all fractions by multiplying both sides by 18. So 9 times x plus 45. The reason I kept parentheses is because of this negative symbol, because there is a negative 1 in front here, and I have to distribute it now. So the left-hand side is 2x plus 4, then 18 minus 9x minus 45. So any questions on these steps? Any questions? Do we understand what we're doing here?
Yes.
Perfect. Good. So now, combine like terms. I have 2x plus 4. I have negative 9x. And negative 45 with 18. What is it? Negative 20. Is it negative 27? Correct me if I'm wrong. Not just now, anytime. So negative 45 plus 18. Good. Now I separate. This goes next to x. This goes next to the other with no x. It was negative. I bring it up to the left-hand side, 11x, because it becomes positive. It was positive. I take it to the other side, I get negative 33, because it becomes negative. It's always better to do this in one step than write negative 2x, minus 6, minus 4, minus 4. It will take you a long time to proceed. It's fine, it's correct, but we should learn a little bit here and there. We should learn some shortcuts. Can anyone give us x?
Negative 3.
That's it. And you can always go back and check. How do I check? Negative 3 plus 2 divided by 9. Does this equal negative 1? No, sorry, plus 1 minus negative 3 plus 5 over 2? I don't know. I don't know. I don't need anybody to tell me whether it's true or false. So negative 3 plus 2 is, do not simplify, that's not allowed. Negative 3 plus 2 is negative 1, so the left-hand side is negative 1/9. If the other side is not negative 1/9, this is wrong. If the other side is also negative 1/9, then I'll say yes. Okay, so I have 1 minus negative 3 plus 5. There was negative 3 plus 2. And this is 2. over 2, which is 1. What did I do? So something is fishy. There's something wrong. So x plus 2 over 9 plus 1, x plus 5 over 2. Okay, and multiply by 18. Good. 2x plus 4. Correct. 1 times 18. Correct. Here. Simplify. 9.
It would be 31.
Yes. Thank you. Thank you. Thank you. Thank you. Okay. So it's negative 31 over 11. Good. Good. Thank you. Thank you. So in order to check, the solution is negative 31 over 11. So now I'm checking. So negative 31 over 11 plus 2 divided by 9, does this equal 1 minus negative 31 over 11 plus 5 over 2? So negative 27 minus 4 was wishful thinking for it to be negative 33. Sorry about that. Thank you. Thank you. Thank you. Okay, so I have to simplify this. And actually, this is a very good problem because this is our next step, looking at rational expressions. Okay, perfect example. So we're going to work on this side first. What is the least common denominator here? So remember, 2 is the same thing with 2 over 1. So the least common denominator is, of course, 11. So we multiply this by 11, we get negative 31. We multiply this by 11, and we get 22. Negative 31 plus 22 is negative 9. So the numerator is negative 9 over 11, and the denominator is 9 over 1. Good. So I copy the numerator, and I flip the denominator. Why am I flipping the denominator? Because that's the procedure of dividing fractions. I copy the fraction from the numerator, and I flip multiplicative inverse, the fraction in the denominator. Okay, so this is negative 1 over 11. The left-hand side is negative 1 over 11. If the color is not good, don't let me write with something that you can't see. Okay, now I have to do the same thing here. So 1 minus negative 31 over 11 plus 5 or 5 over 1, everything over 2. Let's see what we get now. 1 minus. The same thing, the least common denominator is 11. So this is negative 31 plus 55. So when I multiply this by 11, I get negative 35. Negative 31, I meant to say. And when I multiply this by 11, I get 55. I repeat the process, 1 minus. Negative 31 plus 45 is 24. 24 divided by 11, and I flip 1 over 2. I simplify, and this is 12. So 11, again, the least common denominator. Multiply this by 11, 11 minus 12. Yes, indeed. Oh, over 11. Yes, indeed. They are the same. So then I know that this is yes. Negative 31 over 11. The reason it took so long is because there were fractions on top of fractions. So I had to simplify this, get one fraction, flip the denominator. The same thing on both sides, and that's why it took so much work to double check. So indeed, I got negative 11 equals negative 1 over 11 equals negative 1 over 11. Therefore, negative 31 over 11 is indeed the correct solution. Good. That was a good question. Thank you. It was very good. Okay. So do you think we need another example with completing the square, or can we move on? So this is a different type of question. The same thing, complete the square. Determine the constant that should be added to the binomial so it becomes a perfect square trinomial. Then write and factor the trinomial. So the middle coefficient is
Ten.
Good. Please divide it by 2. That's the procedure. Divide that by 2.
5.
Good. Please square 5.
25.
That's it. That's all I need to enter. They're asking us what will be the constant that will make this a perfect square. And now they want us to write the trinomial. But now let's see. Write and factor the trinomial. Okay. So write the trinomial. I don't understand what they want. So they want it in the factored form, or they want us to write this again, x squared plus 25 plus 10x plus 25. I don't understand what they mean. Then write and factor the trinomial. Write the trinomial, do not factor. Oh, okay. So, okay, then I'm just going to write x squared. But this is not how I write x squared. Anybody can teach me how to write x squared?
You put 2 next to that box.
So then I have to put x squared.
No, well time.
So what do I do first? I put x.
2. And then next to that.
I got it. Okay, I have to write x first. Okay, got it. Okay, plus 10x plus 25. I see what they want. They want us to write the trinomial first. Okay, fine. And now they're going to ask us to factor it. Can anyone tell us what is the factor form?
X was 5.
Everything squared. Yes, so how do I write that? And it will allow me to put this in squared. Aha, I got it. Good. Excellent. Good. Anything else from here? Solve the quadratic equation by completing the square. Do we want to work on any? Here we have multiple choice. They're asking us to select. Choose the appropriate process for rearranging the equation. So, what is the middle coefficient?
6.
Good. Divide that by 2.
3.
Good. Square that.
9.
Good. However, this is incorrect because I don't have the option of adding to the other side. This is incorrect because I have 1/6. This is incorrect because I have 1/6. This is the only option that allows me to put 9 to both sides. Add it to both sides. And let's see what they want next. The solution set is. So now we have to take it from here. So let's finish it because we started it. So we have x squared plus 6x plus 9 equals 7 plus 9, which is 16. Okay, so can anyone help finish this one? Finish it up. What does this mean? Because we found that number. I know now it's a perfect square.
X plus 3.
Of course. And the rest is history. We know how to proceed. So we have x plus 3 equals, what do I have to write? I can never forget.
Plus minus.
Yes, and I have to write 4. So I move 3. So x equals -3 plus or minus 4. Can anyone give us the two solutions? One with minus minus and one with minus plus. Anyone, please?
1.
Yes, indeed. Or
-7.
Excellent. That's it. So now I can go back and put them in. So type an integer or a simplified fraction. Use a comma to separate answers as needed. I'm going to put the negative solution first with a comma. Not even there. Negative solution first, and then a comma, and then I'm going to enter 1. And that's it. Are we okay? Can we move on? This is easy. Do you think we can move on? We just did this one at the beginning. Do we need to work on this, something like this? The number of students enrolled in schools for selected years from 2000 to 2008. The data shown can be modeled by the function. Okay, they're giving us, what type of function is this again? We only know linear and quadratic. We don't know anything else yet. Anyone? What type of function is this?
Quadratic.
It is quadratic. Excellent, thank you. According to the model, how many students in thousands were enrolled in schools in 2004? So 2004. So it's 4 years from 2000. So were enrolled in schools. Does this underestimate or overestimate the number displayed by the graph? So the graph says 564,000. But they want us to use the model. This is the model. So what I would do, I would go to my calculator and I will enter that model, clear everything else. And the model was 15x squared plus 350. 15x squared plus 350. And remember what we did with second and table. And I will enter exactly what they want me to enter. It says in thousands, x years after 2000. X years after 2000 means that x equals 0 represents 2000. What x is 2004? If x equals 0 is 2000, 2004 will be x equals 4. Excellent. So this is all I have to do. Just plug in 4 and enter. And I got 590. So the answer is 590,000 students enrolled. And now they're asking us, continue, okay. So this is 564. This model gave us 590, which is not true. The true value is 564, so the model is not perfect. So we got 590 with a model. Does the answer in the previous step, which is 590,000, underestimate or overestimate the number displayed by the graph? So the graph is 564, and we got 590. So 590, of course we don't need to do this with a calculator, but 590 minus 564. So does it overestimate or underestimate the true value? It overestimates, underestimates, or none of the above?
It overestimates.
Yes. And then it says by how much? By how many?
26.
By 26 indeed. That's why I did that. And that's it. Okay. I think you have everything you need to complete this one. So in the next section, the 1.6, there are 7 questions, more applications of quadratic equations. So let's take a look. You choose, you tell me what you want us to work on. Number 1. Solve the equation by any method. I think we beat this one to the ground. I think you can use a quadratic formula. You can Complete the square if you want, which I won't. Quadratic formula will be the best here. It's not factorable. Okay, now this doesn't really belong here because we haven't talked about something like this. So allow me to go through. Let me copy this problem. We're going to work on it together. It shouldn't be here. We have to learn it anyway, but it shouldn't be in this particular step. But we are going to work on it in a few minutes. Okay. The area of a rectangular wall of a barn is 16 square feet. So we have a rectangular wall, and the area is 16 square feet. The area of this rectangular, whatever that is, wall or something else, doesn't matter. Then its length is 6 feet longer than the width. Find the two dimensions. So its length, I'm going to call it L. Its width, I'm going to call it width. It says that the length is 6 feet longer than the width. How do I write this equation?